everybody and welcome today. I'm really pleased to be talking to James Potter from Superstructures, who is going to tell us a bit about his organisation and about structural engineering. Hi James.
Hello, good morning.
Great to meet you. What I will do is I will hand over to you.
Okay, that's great. So yeah, I'm James Potter. I'm Managing Director of a company called Superstructures. We are a consultancy of structural engineers working across the east of England, mainly in all sectors of the construction industry. And what I'm going to do today is very briefly and really briefly give an introduction to structural engineering. I'm quite keen on doing that because I didn't know anything about structural engineering or really the construction industry until I was probably in my 20s. Had I have known a lot earlier, I would have probably pursued that as a career much earlier and made things a little bit easier for myself going in. We'll talk about entry routes a bit later. So what I'll do is I'll give a really brief intro to structural engineering, what it is, and then I think we're going to do a few questions at the end. So if I just proceed, so we'll go from here. So structural engineering. So what I tend to do when I'm explaining this is kind of talk about the kind of process that goes through people's minds when they ask me what I do for a living, because that happens quite often if I'm talking to people at events or if I meet people for the first time, because nobody really knows what a structural engineer is unless you've had to use one before, and not everybody needs a structural engineer unless they're doing large building projects. So when people ask me what I do for a living, I say I'm a structural engineer. They always ask, what is that? What do you do? My first response is I say I design buildings. They then always say, oh, so are you an architect? I always go back and say, no, I'm not an architect. I work with architects to design buildings. People quite rightly, I suppose, seem to associate building design with architecture, but building design really happens as part of a whole design and construction team. So quite important to know that. So I will go back and say, no, I'm not an architect. And then I will say, in a nutshell, we use our brains to design buildings so that they don't fall down. So that's kind of, point number one is to design buildings, structurally engineer them so they don't fall down. But it's much, there's much more to it than that, obviously. If in more detail, we put maths and physics and most importantly, in my mind, common sense into building design to allow them to perform. And we'll talk about what performance is probably in the next slide. We want them to be buildable. So you can, on a piece of paper, draw any building that you want really, but somebody has to be able to build that building, has to be economical, and it has to work seamlessly with other designers. So as I say, architects will be in the design team, services engineers looking at mechanical, electrical, and of course, let's not forget the client, wants a building delivered. They will have certain requirements for that building, whether it's a big new sort of grand designs house, whether it's a school, whether it's a warehouse or industrial building. There will be specific client requirements for those buildings, and we as a design team need to deliver that design for a contractor to construct. So very much part of teamwork but with a focus on maths, physics, engineering and common sense. So here's my quick example. This is a live project that we're working on at the moment. This is an architect's visualization of a building. It's a clubhouse, restaurant, accommodation building at a golf club. As you can see, it's great design, lots of glass. It's got a green roof on it. You can see there a semi-basement underneath. That is the architect's representation. Our job then is to come in and work out how that building is going to be created, what it's going to be constructed from, how it's going to perform. And we do that with larger buildings by creating a 3D model. So the architect will have created a 3D model. Here is our 3D model. So it's the same building from a slightly different view. You'll be able to see there we've got some steel framing at the upper levels and the roof, and we're creating those huge roof expanses. We've got cantilevering roofs, we've got different angles of roofs. It's quite complicated. You'll then see that as we move down through the building, some of you will be able to see we've got some columns through there. We've got some concrete retaining walls, we've got some foundations, we've got some inclined columns as well. So we build that model up, okay, and we make it work around the architectural design. We're putting maths and physics into that model. So what things are we thinking about as structural engineers? So the primary things we're thinking about are forces and loads. So where do those forces and loads come from? Well, lots of different applications of load. Loading the building laterally, moving it around, furniture, what the building usage is. So again, you know, if we've got industrial buildings or school buildings, they will vary differently to people's houses, where people are, you know, just generally sort of living their normal lives. We've got then more complicated things like internal stresses, thermal expansion and contraction within those concrete elements and those steel elements. And then we're looking at performance. So, you know, I mentioned in the first slide, how is that building going to perform? How is it going to deflect? How much movement can we take on the floors? How much movement can we take, you know, in terms of swaying around in the wind, vibration? And all buildings will move around, we know that, but there is a limit to those movements, and there's a limit. Normally, you know, things start to crack. Cracking isn't too much of an issue in industrial buildings. They can take a bit more cracking than somebody's multi-million-pound house. So we need to be thinking about all of those things. We'll also be thinking about the ground conditions. All of our buildings sit on the ground, and they all sit on foundations. And I talk about ground when we look at the ground as a squish factor. So what is the ground like? Is it sandy? Is it clay? Is it bedrock? How much is that going to squish and move under the load of our building? And how do we best structure those foundations so that the ground supports it? Really important to us as engineers and designers that we look at aesthetics. So what a building looks like. We want to keep those structural elements, you know, the columns, beams, as slim as possible. Sometimes we want to work around lots of glass, especially now in modern buildings, long spans, open plan areas, which means that, you know, clients in certain applications don't want columns everywhere, especially not in industrial warehouses and huge restaurant spaces, and also in their houses now. If any of you have watched grand designs on the TV, you'll see, you know, large, very, very large rooms without columns and walls in them. We, as structural engineers, love cantilevers, where elements just sort of float in midair. You know, that takes a little bit of design, a little bit of thinking about how those loads get back to the ground. And we'll also be looking at new materials. So we'll be designing in glass, timber, engineered timber, composites, all of those sorts of things. And, you know, sometimes those elements can be exposed. So some really exciting projects, you know, some of you might have seen the steel frame exposed on the outside of some skyscrapers, and internally you'll be able to see really nice timber elements or steel exposed concrete, polished concrete slabs, stuff like that. So, you know, there's lots to think about, there's lots to engineer, and it's really working as part of that design team to deliver that well-engineered design. Where did I start? So this is really just to give some of you a background in terms of, I didn't have a normal route into structural engineering. So if you're a bit late in terms of making your mind up in where you want to work and your career choice, it is never too late to do that. I actually did my A-levels in graphics, art and physics. I did my degree in product design, so I thought I was going to design stuff like mobile phones and tablets and stuff that we haven't even thought about yet. I actually ended up getting my first job as a structural technician, so didn't know anything about structural engineering or construction. I then worked my way up with a bit of retraining and some part-time education, learning on the job, really important, and I gained my qualifications to be a chartered structural engineer. Okay, where can you start? So a good place to start, A-levels or a similar diploma. So maths, physics, design and engineering are all really good subjects if you want to go into structural or civil engineering. Should briefly just explain the difference. Civil engineering covers really both civil and structural engineering. Civil engineering tends to be roads, drainage, infrastructure, rail, that sort of stuff. And then people will specialize into structural engineering. So if you were going to do a degree, You would do a degree probably in civil engineering. There are some structural engineering degrees, but they're few and far between. So you would do a civil engineering degree course. You could do that full-time, part-time, or something we're really keen on at the moment is a degree apprenticeship. Okay, so that degree apprenticeship, we have 4 apprentices working with us at the moment at various different points of their career. That degree apprenticeship is a 4-year degree course. You do 4 lots of 1-week stints at uni every year, and then the rest of your learning will be distance learning. Plus, we will be teaching our apprentices continuously on the job. You'll be learning on the job. At the end of that 4 years, you do another year to gain a formal qualification. So I really like the degree apprenticeship route. In 5 years, you'll have a degree. You'll have 5 years worth of working experience with us, which is amazing, or another consultancy, of course. And you will have a formal qualification as well, an engineering qualification at the end of it. So I think that's a great way to go. Once you've got your degree, whether you do a full degree course or a degree apprenticeship, you will probably then want to move on and work towards your chartership, which might take you another few years worth of learning and experience. There are other roles, not just a pure structural engineer. You can move into being a structural technician, which is much more involved in the kind of 3D modeling aspects that we've looked at, drawing, helping principal engineers with their work, going to site with them, that sort of stuff. So slightly more of a support role, as technical, slightly different, and a site engineer, for those of you who might think that working outside appeals to you more than predominantly being office based. So you could work as a site engineer on big projects for a contractor. You would be on site making sure that the building contractor is building their buildings as per our design, really. I mentioned office and site working. As a pure structural engineer, you know, the thing I like about it is it's split. We might do half a day in an office, half a day on site. We might do you know, very mixed projects. Sometimes we'll be doing calculations, sometimes we'll be doing 3D modeling, sometimes we'll be doing some drawing work, sometimes we'll be meeting with clients. So it's a really, really varied career. Every day is different, every project is different, every design team is different, which is why I'm, you know, sort of really attracted to it. And you know, finally, the kind of best part of the job for me is standing back at the end and looking at our finished buildings that we've spent kind of weeks or months designing. You'll be seeing them at points, you know, you might go out to an empty field at the start of the project, and then a year or so later, you'll be standing back looking at an amazing building that you've put your common sense, maths and physics and your brain into, and you'll know all about how it's standing up and how it's performing under its loading. So that is my intro to structural engineering. There's an idea of some of the projects that we work on and some of the projects that you could work on. So we've got some industrial buildings there, some big grand design style houses, some schools, some cantilevering elements, barn conversion in there. So, you know, really, really varied career, really interesting career in construction.
James, that was brilliant. Thank you so much. I've learned so much. I've made so many notes, like cantilevers, like it sounds like an element floating in midair. So anybody watching this with more technical knowledge than me will probably have got even more out of it. But that was really interesting. Thanks for explaining sort of the difference in terms of how you might work as a team as well. And you talked a bit about kind of like what your day looks like. If you were kind of like somebody in an entry level role into your organisation, for example, one of your apprentices, could you talk us through what one of their typical days might look like, from sort of, you know, your coffee in the morning maybe through to the end of the day? Absolutely,
yeah. So as a practice, you know, we're really, really keen on development of people. So apprentices coming in, I would hope this is the same for other companies as well. So as an apprentice coming in, you know, I would hope the days of an apprentice doing photocopying, filing, making the tea, I would hope those days are over.
Yeah.
You know, the days for us, a day for an apprentice would be coming in, like I say, they might be visiting a site on their way to work, for instance, right, having a look around a building with one of our senior engineers. They'll be coming into the office and they would be maybe doing some drawing work on AutoCAD. They might be doing some modeling work, might be doing their own calculations on some software. Again, you know, gone are the days of bashing away on a calculator all day, although that is very important at first. We have kind of harder work out of those calculations. But yeah, so a varied day, like I say, split between site and office, and calculations, drawings, modelling, a lot of learning and development with their senior engineers. They'll be sitting down at the start of a project with them and saying, what's the design concept here? Are we, how are we going to structure this building? And then, mixing up with their 1 day a week where they'll be doing distance learning. So when they're not at university, 1 day a week will be, doing some uni assignments and doing some learning. So that real kind of continuous learning, building of experience as they work through the job. Yeah.
Oh, that sounds brilliant. And you talked about sort of some of the hard skills like maths and physics, and maybe common sense as well in terms of it being a hard skill. But in terms of those kind of softer skills that you think that it maybe takes to be a good structural engineer, what might they be?
So I'm going to answer that second, because you just reminded me something really important. When I was at school and at college, I hated maths and physics.
Did you?
I failed my AS maths because I was so uninterested in it. I didn't really bother turning up. That's not a good thing to do, but it just shows my lack of interest in it. What I found was that when I moved into structural engineering and I was applying maths and physics to building design, and I had clients saying, how wide can we make this huge glass opening?
Wow.
And I'd be thinking, okay, well, how wide can we make that glass opening?
Yeah.
And when I was applying maths and physics to that, I then found it so interesting. So for those people who think, oh, maths and physics is really boring, the classic, we're studying Pythagoras at school and we're never going to use it. This is where you apply it, but you apply it in a really, really interesting way. Okay. So I just wanted to say that. Softer skills, communication.
Yeah.
Communication with the team in the office, talking to your senior engineer, being able to discuss projects, sketch ideas on a piece of paper, being able to call architects on the phone and just say, oh, I'm just unsure about how you want this detail to work. Can we jump on a video call and just share a screen? Those sorts of things enable people to really progress in the job quite quickly. So, communication and, like I say, the common sense stuff.
Brilliant. And I wonder as well, maybe sort of almost like you were reflecting on there, almost like that element of curiosity, like, well, how big can I make that bit of glass? Or how
absolutely
like that sort of professional curiosity that you get.
Yeah, indeed. And sort of people saying, oh, well, could we put another floor on top of this building? And you might think, oh, I don't know, great question. So then you'll be looking at your maths and your loading and looking at your ground conditions, and again, that stuff is really interesting. It's really varied, and when you step back from that building, when it's complete, it's so satisfying. And these buildings will be standing for hundreds of years probably, and every time you drive past them, you can bore your friends and family with the fact that you've designed them, which is great. So.
Oh, James, that was absolutely brilliant. Can I just end by asking you very quickly, if you had to speak to your younger self, starting on your career, what bit of advice would you give yourself?
I would probably I'd probably tell myself to be a little bit more open-minded in terms of what I wanted to do. So from a really young age, I wanted to be a car designer, actually, first of all. I'm obsessed by cars, and I still am, but I wanted to be a car designer. But I was so focused on that product design, I hadn't opened my eyes to construction, for starters. I didn't know the huge number of roles in construction. I always say to people, I talk to young people and they say, oh, I want to be a lawyer, I want to be a photographer, great. All these, you can do all of those things in the construction industry. If you want to be an accountant, you could be an accountant in the construction industry, So I'd like to be more open-minded, and I didn't consider business at all. And I now own and run a business, and I love doing that. And at the time, again, so focused on being a designer that I mean, business studies would just have been something that I would have immediately dismissed, and it's something that's incredibly interesting. So yeah, just being a little bit more open-minded and looking at those opportunities when they come along, I think is something that I would probably benefit from.
Oh, James, that sounds like absolutely brilliant advice. Well, thank you so much for your time today. That has been so interesting. It's been great to meet you. Thank you.
My pleasure. No problem. Thanks a lot.